This demonstration shows how MediaView can access the built-in Mathematica program in two different ways. I have a demonstration MediaView document that's been prepared. My cursor is on it. It's called MMA Examples. I'll double click on that, and then we'll see that MediaView is going to open it, and it will install some items here that represent the two different ways of accessing Mathematica. The first example is what I have called a live equation example. It's so named because the representation of an equation in the document can actually be accessed by MediaView and then sent to a Mathematica server anywhere on a network that the next workstation is connected to. And in fact, under the first title, Live Equation Example 1, I've just added some explanatory information that points out that the live equation capability is accessed via the Unix pipe facility. That is just on this machine, just opening a pipe directly to the Mathematica server. And without going into the details, the relevant piece of information here is in the quotation marks /net, that would be a machine located on the network, /sunset, which is the name of the machine that I'm currently using, and then a directory called next apps, and then finally an application called Mathematica app, and then in addition it is going to another location under Mathematica app and loading kernel applications, and the kernel is another name for the Mathematica server. So the first example that I have is this matrix equation. It's a two-dimensional rotation equation involving rotation around the axis of the angle theta. And note that there is a small icon here. This is supposed to be a magnifying glass, and that means that this is inspectable in MediaView terminology. So if I click on this, I'm going to open up another panel, and at the same time, just opening up that panel has established a Unix pipe connection with the Mathematica server, so it is currently live. And the only parameter that I can vary in this particular equation is the angle theta, which is currently set at a value of 0. So I'll change that to minus 0.2, for example, and then I click on the evaluate button, and in this window above here there will be a stream of textual information, which is exactly what is being sent to the Mathematica server, the kernel, and then there will be the response from the kernel in that same window, showing what it is sending back, including the calculations, and I've asked to have a graphical entity plotted as well. So I'm clicking on that. There's all the input information, and what's coming back after evaluating that is a new orientation of this small house that I was working with. And so the link then is from this equation to whatever is displayed in this location. I could now take, and of course I can do this operation as many times as I want to get exactly the orientation I'm looking for. But at this point, if there's a button called Copy PS, this has all been sent to this machine from the server in a form of PostScript. So I'll copy that, and now it's on the clipboard. And I can go down here and I'll just select this original version of the orientation of the house, and I will go up to the Edit menu and click Paste. And there is the version that I've received from the Mathematica server, the kernel that I've just now pasted into that document. Now when I click this X box to close this, the link between MediaView and the Mathematica server has just been broken. And every time there's a new live equation, as there is just down below a bit, every time I activate the link to Mathematica, it starts all over again. So here again is the magnifying glass so I can inspect this. This is a fairly simple example of just showing what this function sine of x and y, and the rest of this is just specifying a Mathematica command to use combinations of red, green, and blue in order to represent the height of this equation, and that is all plotted down below. So we see various shades of green and magenta and so on. So again, I'll activate a link to the Mathematica server. Now there are actually three variables that I have to work with: red, green, and blue, and those are currently represented here. The maximum value is 1 in this coordinate system, is 0.5 for red, 0.8 for green, and 1.0 for blue. So what I'll do just arbitrarily is change the blue content to 0 and then evaluate this equation, and now we see the stream of information that's going to the Mathematica server, and it's sending back information with a new plot that has slightly different coloration, and we'll see that in the corner closest to the eye, it's gone from a bright magenta to a very, very dark red. So again, if we do a copy PS, we've taken the results out of that window, and I can elect again to replace what I've done, and I could create a new document, and there's all kinds of possibilities, but I'm just showing the capability in situ right here rather than opening new documents. So there's the resultant three-dimensional plot by just changing the value of blue to 0. The last example that I want to demonstrate is what's called a Mathematica notebook example. The one I've just showed utilized Unix pipes to connect from MediaView into the Mathematica server. In this case, this icon at the bottom, which is a sphere inside of a cube, will actually launch the Mathematica application, just as if I had gone to a location and double-clicked on the application's icon. But I'm doing it directly here, but at the same time I'm sending information via what's called a Mathematica notebook. The stream of information that was sent when we were using the pipe can be captured in a file, and so that access via next step from MediaView is actually to invoke a method called application workspace open file, notebook file, and so on. And again, it can be anywhere on the network, and I'm specifying specifically the highest level net with a machine called Sunset, Next App's Mathematica app. So let's click on that, and now I'm sending the information that is built into MediaView as in the form of a Mathematica notebook. And what is happening here is another application is opening, so we'll just, and one of them is just a window with nothing in it, but the one we're interested in is this information that was in the notebook, and it says do a density plot with some trigonometric functions. And now I'm going to ask the server to actually evaluate that and produce a resultant graphic. So it is working. Up at the top there's a notification at the window bar. It says it's running. So the Mathematica server now is active and calculating these various instantiations of this filter function that's represented by these shades of gray. And when the running goes away, this will be complete. And it's done, and so we can see that there are 6 instances of this filter function being plotted for different values of parameters. And now I can actually animate this. So I can activate everything and then enter a command that starts the animation going. And so now what we see up here, just in this portion of the window, is the complete animation from one parameter value used in the filter function to another. And we'll stop that and close that up. And now over here, just to make it clear, here is the Mathematica control bar. Because we actually opened up the Mathematica application from MediaView. And so I will quit that application and say no, don't save anything. And that's all done. And so what we've done is to show two different ways of accessing the Mathematica server from MediaView. So I'll save this, quit MediaView, and then just to show that all the changes that we made have been saved, we'll reopen everything again. And MediaView will open its window and then start parsing the contents of that file, MMA Examples. And that will show up in just a moment. And so just to go from top to bottom, here are the changes that we made by doing a two-dimensional rotation on the original version of this simple house. And then here are the changes that were made to the three-dimensional RGB plot. And there were no changes made to the Mathematica notebook. So just this has been a brief overview of the powerful techniques of having an embedded application in MediaView and accessing server client capabilities, in this case using the Mathematica server, which when it was active with the live equation, contained equation information on the server that was sent from this client MediaView and passed information back to the client MediaView for the display.